video, we want to solve a system of linear equations with 3 equations and 3 variables. Okay, as I just mentioned, I will be explaining first the concept and the method, and then we start solving it through algebra. So here we would have 3 equations in which each equation would have 3 variables. Let me write down the equation. X minus 3y plus 3z is equal to 4. As you can see, I have one equation and there are 3 variables, x, y, z. And then the second equation is 2x plus 3y minus z equals to 15. The other one is 4x minus 3y minus z equals to 19. So I will number these equations, equation number 1, equation number 2, equation number 3. As you can see, in each one, there are 3 variables. The same 3 variables are repeating in each equation. Here, we would have a line in 3D dimension, okay? So we wouldn't be concerned that much about the graphing method, but we want to use the algebraic method and Kramer's. For this one, we have to consider a combination of 2 equations, okay? And then try to eliminate one variable. So let's say the possible combination would be 1 and 2, 2 and 3, and 1 and 3. Whatever combination works for you, you have to consider 2 combinations, and then from each, you have to eliminate the same variable. So for now, I just pick a pair of equations to eliminate. I pick equation 1 and 2. Okay, as you can see here, let me write it down. I pick equation 1 and 2. Okay, so what I can do, I can add them to one another. And then by adding them, here negative 3y and plus 3y, because y has the same coefficient but different sign, it will be eliminated. Okay, that's the good thing. So let me add it together. So 3 combination of these 2. So I consider 1 and 2 equation. Equation number 1 would be x minus 3y plus 3z is equal to negative 4. And equation number 2 is 2x plus 3y minus z is equal to 15. Now, let's see what happens. I will try to add these 2 equations together, and by doing so, I will be eliminating one of the variables. Okay, so here, the ideal one would be y, because here the coefficient is negative 3 and here is positive 3. So simply by adding, I would have 3x minus 2z, it's equal to 11. Okay, 3x plus 2z is equal to 11. Now, the second combination I can consider is let's consider equation 2 and 3 together. So that would be 2x plus 3y minus z is equal to 15. And equation number 3 is 4x minus 3y minus z, it's equal to 19. So again, what I want you to pay attention here, with this pair of equations, you have to be eliminating the same variable that you did in the previous equation. Okay, so here we eliminated y, here we should be doing the same. And we are lucky because these 2 can cancel out. And then the answer is 6x minus 2z, it's equal to 34. So if you look at here, you will end up with two equations and two variables. So I have 3x plus 2z is equal to 11. This is one equation. The other equation is 6x minus 2z is equal to 34, right? So you started with three equations, three variables. Now you reduced it to two equations, two variables. What you can do here, again, you can use any of the methods to solve and find the value of x and z. For now, I will consider I don't consider the graphing method or Kramer. I will use one of the methods which involve algebra. So by adding these two, they will cancel out. 9x is equal to 45. So from here, x is 5. Okay, remember the intersection point would have three coordinates. It has x, y, and z. So you found the value of x. Okay, now you need the y and z coordinate. The x is found, so you can plug it in any of these equations, right? And then find the value of z. Let's say here I will substitute x as 5, so that would be 15 plus 2z equals 11. Okay, so from here I would get, if I plug in x equals 5 in 3x plus 2z equals 11, then it would be 15. It moves to the other side, would be negative 15 plus 11, negative 4. So 2z would be negative 4. Z would be negative 2. Okay, so z would be negative 2. So far, I found the value of x, z. Now, I have to substitute x and y in one of the original equations, okay? In one of the original equations with three variables and three equations, and get the value of the of the y, okay? Okay, now I have the three equations here. Let's use equation number 1. So the x value we found to be 5, the z is negative 2. So the x is 5, the z is negative 2. So let's solve it. For solving this, I will be using the green pen. So it would be 5 minus 3y minus 6 is equal to negative 4. So here negative 3y, it would be minus 1, moves to the other side, would be plus 1. Okay, so the y would be 1. Right? Now, we can go back here. The intersection point would have the x coordinates as 5, y as 1, and the z as negative 2. Whatever method you use, you should get the same answer. Now let's do another example. Okay, let's move on to the next example. Here we have three equations again. The three equations are in terms of x, y, and z. So we are in three-dimensional plane. And then we want to know where these three lines or planes will intersect, okay, with one another. So here we start with three equations, three variables. Remember, we should start by considering pairs of equations and then eliminating one variable. So what I'm thinking here, I would consider to eliminate y, because here this and this, they have the same coefficient but opposite sign. So I would consider equation 1 and 2, and then I write it down, 2x plus y plus z is equal to 7. The second one is 2x minus y plus 2z. It's equal to 6. Now I will eliminate y as I just mentioned. This will cancel out. 4x plus 3z is equal to 13. Okay, so remember, which variable was eliminated? Y. Now this second combination, I want to take equation number 1 and number 3. So 2x plus y plus z equal to 7. And equation number 3 is x minus 2y plus z is equal to 0. Okay, so here I must eliminate the same variable. I have to eliminate y. So what I have to do, I have to multiply the top equation or equation number 1 by 2. Okay, so if I multiply it by 2, this will be 4, this will be plus 2, and this will be 2z, and this will be 14. Okay, and when I add them together, the final answer would be 5x. This will cancel out with this one. I have 2z here plus z. That would be 3z. And then what I have here as a constant, I have 14. Okay, the next step, I have to take these two together. Okay, two variables, and find the value of x and z coordinates. Okay, so 4x plus 3z equal 13, and the other one is 5x plus 3z equals 14. The good thing is here, if I multiply the lower equation just by -1, the 3z will cancel out with -3z. So that would be negative, that would be negative, that would be negative. So now let's simply add them together. 4x minus 5x, that would be -x. This will cancel out with this one. So here that would be -1. From here, x is 1. Okay, so we found the x coordinate. Now let's plug it in one of these equations and then find the value of z. So here I use this equation, 4 times 1 plus 3z is equal to 13. So here 3z is equal to 13 minus 4, which is 9. And from here, the value of z is 3. Okay, so far we found the value of x and z. Now we can plug it in one of the equations with the 3 variables and then find the value of the third variable. So here let's go back to our original equations. Okay, I consider the first one. The x is 1, so 2 times 1 plus, I'm looking for the value of y, so y is missing. The z value is 3 equal to 7. So y equals to 2 plus 3 is 5. Move it to the other side would be -5. So y would be equal to 2, right? And if I want to sum it up, the intersection plane, because in 3D, it wouldn't be a point, it would be a plane, okay? So that would it would be 1, 2, and 3. 1, 2, and 3. That's the value of x, value of y, value of z. A word of advice, whenever you solve an equation or system of linear equation, make sure when you find the values, you check back your answer. What I mean is, here you have the value of x and y. Maybe substitute it in the third equation and see if satisfy this equation. Then you would know for sure that you solved it correctly. And I will show you how to do it. Okay, so here I'm using the third equation. I use x as 1, y as 2, so 2 times 2 is negative 4, and z is 3. Okay, and it must be equal to 0. 1 minus 4 is negative 3. Negative 3 plus 3 is 0. So that means your answers are correct. I hope this video explains how to do 3 variables and 3 equations, system of 3 equations with 3 variables. I'll see you in the next video.